Hello, in this video I'm going to show you how to solve or evaluate exponents. This means that you are actually going to do the math and solve the problems. Let's take a closer look. If we wanted to evaluate the expression 4 to the second power, we need to take a look at what that really means. Down below here is some key ideas to give you about solving this problem. An exponent tells you how many times its base, or the big number, is used as a factor. Remember, factors are when we multiply by each other. Exponents are used to write repeated multiplication. So here's an example for you. We have a base of 5. 5 squared, which you can see right here. 5 squared is really 5 times 5. 5 times 5 is 25. 5 to the third, or 5 cubed. This one is 5 times 5 times 5. So 5 times 5 is 25, times another 5 is 125. So that's how we're going to be solving these. 5 to the fourth power is 625. And 5 to the fifth power is 3,125. So if we're going back to the top here of solving 4 squared, then what we really are doing is 4 is the base number. That's the number we're going to be multiplying. And the 2 tells us how many times. So 4 times 4, that's 2 times. 4 times 4 is 16. So the answer that we were looking for on the very top here to evaluate the expression would be 16. We're going to try some more examples. First one up here, 5 squared. Now remember, 5 squared means that we are taking the base number of 5 and we're timesing it the amount of times that we see the little number, the exponent. So we're doing 5 times 5. 5 times 5 is 25. So 5 squared is 25. 2 to the third power, or 2 cubed, means 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 2 cubed is 8. 1 to the third power. Remember, we're multiplying our base of 1 3 times. And it's always going to be the 1. Well, 1 times 1 is 1. 1 times 1 is 1. So in this case, because we were multiplying by ones, no matter what the exponent is, it is going to give us an answer of 1, because that's the identity property of multiplication, when you get an answer of 1 when you multiply by 1. Now this one's a little bit tricky. This one is 0 times. Now this has a special rule to it. Anytime we do to a power of 0, your answer is always going to be 1. So it doesn't matter what your base number is. If you are to the power of 0, your answer will be 1. Now sometimes you'll see problems written in words like this. What is 3 to the power of 1? What that really means is 3 to the power of 1. So the power is the exponent, the little number. Well, this means that I have 3 one time. Well, if I have 3 one time, then I only have 1 3. What is 2? That's our base. To the third power. Anytime you see that power word, it's the exponent. So 2 to the third. Again, that means 2 times 2 times 2, the 3 times. 2 times 2 is 4. 4 times 2 is 8. It's always good to show your work in your problem so that you have good proof for your answer. So 8 was our answer for 2 to the third power. Some reminders. This is a good time to take some notes in your notebook. Stop the video, pause it, make sure that you can get it all down so that you can remember these. Exponents. Exponents show repeated multiplication. So just like multiplication is repeated addition, exponents is repeated multiplication. Exponent represents how many times a number is multiplied by itself. So in exponent form, that's when you see the little number. So 5 to the third power, or 5 cubed. In word form, we would call this 5 to the third power. Again, this one also could be called 5 cubed. Expanded form is expanding out or making your chain of numbers that you did in the problem. 5 was our base number, so we're going to use the 5. And the exponent told us we're going to use it 3 times. 1 time, 2 times, 3 times. Standard form is giving the actual answer to 5 to the third power. So 5 to the third power is 125. A couple key things to keep in mind. Any number raised to the power of 1 is itself. Any number raised to the power of 0 is always 1. So again, this is a great time to take some notes in your notebook and pause the video so you have extra time. Keep practicing solving those exponents.